Hi, I'm Drew. Welcome to the Beggars Woodshop. I admit, the information I'm using will apply to your dust collection system, even though I'm not using your particular brand. I have one I use, you have one you use. The person who's watching this and left the comment above yours, they have a different one than you. But the math and the understanding of how all this works does apply. Now, with that being said, why are we here? Well, a while back, I saw on the Shopsmith owners Facebook group, somebody had a dust collector. They had a DC 3300, which is what I have, but it didn't have the front inlet that had the place for all three 2.5-inch hoses to be plugged into. I recommended finding that front inlet, but everyone else was kind of pointing out, oh yeah, you can find a 4-inch housing for here's so you can adapt. And someone commented on my comment saying, well, I have 4-inch and it works out fine, because I did say they don't do well with 4-inch. And I had told this person who commented, well, my information comes from a Nick Engler video and a forum post, and there's also a little bit of information I got from a Stumpy Nubs video. I will leave a link to that video, the Nick Engler video, the forum post, as well as the website with the PDF file of all the stuff I'm about to show you and go over. Full credit to Nick Engler. Full credit. Man's a genius. So I thought I'd start talking about the whys of the dust collection system for Shopsmith, but I decided too, and why some of you are here, why not talk about just dust collection as a whole and how to set up your run and all this other stuff. So that's what this video is. It's to show you, those of you who are not Shopsmith users, how to justify the fittings, the sizing, and how to set up your dust collection. But primarily, my main reason is to hopefully put an end, once and for all, the debate about a Shopsmith DC 3300 dust collector, single stage, and whether or not, in fact, I say not, it cannot handle 4-inch pipe for your run. Okay? Now, I encourage you to watch this video multiple times. A lot of this information is more simplified thanks to manufacturers, but it's also going to be quite helpful because I'm going to cover size of the pipe you might use, or housing, however you want to put it, as well as setting up a run. We're going to do a mock run here in my shop. Okay. This is a lot to talk about, and there's a lot of math, so please come back and watch this if you have to. Alright. Get out your calculators. Here we go. Hey everyone, I just want to take a pause here from whatever it is I'm working on, just to say one thing. Thank you. Thank you for your support of this channel. From your likes, your comments, your subscriptions, your views, and sharing this out there with other people. I thank you. You've helped this channel grow. If it wasn't for you guys, I don't know what I'd be doing. Of course, I'd also like to thank those of you who have supported in other ways, from equipment, be it here for the shop, or for being able to film these projects, as well as those who have contributed financially. There's a GoFundMe link down in the description below, so thank you to all of you who have contributed that way, but also personally, those of you that know me. So again, thank you, ladies and gentlemen. Thank you for helping this channel grow, and I hope to continue to bring you content that you enjoy. Now, let's get back to whatever it is I'm doing. The recommended power for a dust collection system for a wood shop should be between 3,500 feet per minute, or better, to 4,000 feet per minute, or better. Now, manufacturers have already taken care of this, but why does this make a difference? Well, you gotta think about your pipe. Pipe diameter housing, however you want to put it, for the run, in other words, your flow of air in your dust collection system, we gotta solve for a lot of that. Manufacturers these days are commonly using 4-inch pipe. That's a standard. A lot of tools have 4-inch pipe, and the dust collection system can automatically handle it. But there are some that have 6-inch pipe. And you know what? That's fine too. Some people will start with 6-inch and then branch out to 4-inch. And in some cases, for a dust sweep or for smaller tools like any kind of fest tool really, they add a smaller pipe. Though that's not really recommended. Go check out the Stumpy Nubs video on why that is. So, if I were to create a run, I would need to know, well, what size do I need, which I have to go off my tools and my dust collector, but also, what is the cubic feet per minute that dust collector handles? And that's what we're going to do the math on. So, how do we solve that? Well, we do a little math. Let's start with the size, diameter of our housing. Our PVC, our ductwork, whatever you want to call it. So, let's do a quick little math here. This information I will again make available. Links in the description. Here we go. Let's see. Okay. We know that, if I get the right paper, we know that in order to find the square area of a circular object, we have to do the mathematical calculation of pi r squared. Yay! We're going to simplify pi r squared here. We're going to actually do 3.14, just those first 3 digits of pi. Make it nice and simple. And we're going to figure it out. Well, let's see. If we do a 4-inch pipe, well, the radius, which is r in our mathematical equation, is 2. Well, what's 2 squared? 4. Crazy, I know. So 3.14 times, well, 4 is 12.56. Okay, 12.56. But that's square inches. Remember, we're dealing in cubic feet. Inches, feet. So we've got to use 144. We use 12 inches equals a foot. 12 squared is 144. So 12.56 divided by 144 is 0.87. What's that? Well, I'm getting there. Now we have fun. We're going to take the cubic feet per minute that our dust collector can handle. Let's use, tell you what, let's use the what's the lowest one I got on my list here? Okay, yeah. Let's use this Laguna I found. It had cubic feet per minute of 650. So, 650 cubic feet per minute divided by 0.087 equals... That's a lot. That is a lot. So we can use a 4-inch pipe. That's great. That's a higher velocity than 4,000 feet per minute. Feet per minute. Why do I want to say that? No. 4,000. Oh yes, that is right. Feet per minute. I've been saying it wrong as I've been practicing this whole time. Now I say it right and I correct myself. Okay. Well, now, let's use my dust collector. My dust collector has a cubic feet per minute at 330. Okay. 330 divided by 0.087 is 3,793.1. That's fine. That's fine, right? I mean, we dropped below our magic number of 4,000. We're still above 3,500, right? Well, here's the thing. According to what I have learned, following the neck angler video, 3,500 you want at the dust collector. 4,000 you want at the tool. We've dropped below that magic number of 4,000. Now, if you really want to get into a deep dive of why my particular machine, my Shopsmith DC3300, will not work with 4-inch pipe, and if it does, you have to have an extremely short run, I'm going to leave a link to a Shopsmith forum that talks about this, and anywhere you see Nick English speak, he will go over the science. The man knows what he's doing. So what am I supposed to use? Well, the smaller the pipe, the faster the velocity. But you can't necessarily build a dust collection system with 2.5-inch housing. And that's the majority of what I've got around here is 2.5. In fact, I will show you the only piece of 4-inch in my shop. A dust shield. I use this on my lathe for collecting the sawdust and some of the shavings. I put an adapter on it. That's it. Well, if I can't use 4-inch, why don't we try 3-inch? That's a little bit bigger, and if we reduce down to the 2.5 that's on the standard hoses, we're still okay. Now, let's try this math again. Well, oh yes. What's half of 3? Well, that's 1.5. 1.5 squared is what we're after. So, 3.14 times 1.5 squared is just over 7. In fact, I'm going to add the decimals. Why not? 7.065. Great. 7.065 divided by 144, 0.049. 0.049. Alright, now we're going to have our velocity right here. 330 cubic feet per minute over 0.049 equals... Well, there it is. 6,734.69 feet per minute. Now that's fast. It may not be as fast as some other machines, but it's fast. That's great. That's actually great. Now we know 3-inch pipe can handle it. If we start going down in pipe, we'll really see that it can handle it. Why is this important? This is important to help build a run. And we're going to go over building a run, and we're going to build one. Kind of a temporary mock-up here in my shop. I'm going to show you a 3D model of that. And that's why when people say 4-inch is fine on a Shopsmith, no, it's not. Now, admittedly, the new Shopsmith DC6000, that has cubic feet per minute of 600. All right, quickly, will you do the math for me, please, future me in the editing room? There you go. They can handle some things a little bit better. Oh, I'm sorry, did you do that at 3-inch pipe? Would you mind doing that at 4-inch pipe, please? Ah, that's quick. Well, there you are. There you are. Same mathematics. And that's how that's what it can do for a 4-inch pipe on the DC6000. Now, I'm going to give you a quick list here on the side of a few different dust collectors that I looked up, and I'm going to give you not only the cubic feet per minute, but also the static pressure that it offers. And that's also important because we want that to help with the suspension on the pipe. Now, please take note, these are single-stage dust collection systems. Just for fun, let's throw in a 2-stage. Yeah, just to be fair, just to be fair. Now, when we build a run, what we have to remember is that we need to have our static pressure. Here's a little chart for you. This chart shows the drop in static pressure per linear foot of various hoses, as well as the static pressure drop for various pipe fittings. Ignore the T connector, we're not really going to use that. We'll use Y connectors and elbows, although you could make the argument about certain T connectors being certain types, but we're using plumbing fittings. Alright, we're not going to use standard PVC where it is a straight T. Now we're going to have a nice little gentle curve into it. Alright, enough of my blabbering. I hope some of this is making sense and I'm not just talking gibberish. again, I invite you to go over this again and again and again. I've had to watch the videos several times, read through it several times, and try to understand it for myself lots of times. Now, I'm going to build a run, and I'm going to show you how my run works. If you don't need to know anything about the run, and you just want to finish with the fact that I'm making the argument that 4-inch pipe doesn't work on a DC3300 from Shopsmith, you can skip to the end of the video, which is found right there. That's your time code. Alright, let's build a run. A bit ago you heard me mention static pressure. Now, static pressure, of course, it has to do with how much we're in the tube, and how you determine that has to do with sucking up water through a tube over certain inches. I'm not explaining it the best, I know, but manufacturers have given us this static pressure already. We just have to research it. I was unable to find it for the DC6000, but what I did find was kind of mixed answers, so I will not be calculating that here. We'll just be calculating mine. Static pressure for the Shopsmith DC3300 is 4.6 inches to 7 inches. It depends on your hose configuration. 7 inches is the singular hose, 4.6 for all three. Now, that's fine to use the singular hose, but we're going to use all three hoses in this case. I know, Drew, that there's greater static pressure. Yes, but I'm following the method that was used the other way. So, again, this is just a mock-up. We are going to have all three hoses come together into a little junction box that Nick Engler nicknamed the octopus. I almost called it the spider. It's the octopus. And you can see what it looks like here. And there's also a link of where you can get the plans for this if you choose to build it yourself. So, from our little octopus, which is going to act as a junction box, we are going to go straight up. And we are going to go straight up 4.5 feet. And then we're going to come to a nice 90-degree turn. Again, this is all in 3-inch pipe. And we're going to come across. We're going to come across about 2.08 feet. Now, I know, I prefer to do this stuff in fractions, but we're going to keep it decimals for a reason, all right? And again, this is just a quick mock-up. After we come across a little bit here, we're also going to come to a T. It is a T, even though it kind of looks like a Y. I'm sorry, it's just the way the plumbing fittings are working here. From the bottom of that T, we'll go down 2.91 feet. And at the bottom, we'll have a little box and that can convert from the 3-inch to the 2.5 inch. It's a nice little conversion. You may choose to put your blast gate here, but I'm more in putting the blast gate a little higher up if I can. Now, back at the top, we're going to go across again. And we're going to go across 1.5 feet. I know it doesn't sound like much, but we'll then have another 90-degree, and then we're going to come down again 2.91 feet. At the bottom, we have the option of adding hoses. And I'm only going to add 2 6-foot hoses. I'm not going to do a full 8-foot here. Just to be sure. Now, you could, at the end of your run, just before you turn 90 degrees and go down, you could put a reducer to go down to 2-inch pipe. Same with when you get to the Y. As you go down, you can go to 2-inch pipe and do a conversion from there. I'm going to go 3-inch pipe this time. What next? Well, put up our blast gates, we'll put up all this stuff. Now we need to measure. This is where the calculations come in. Remember, our static pressure. How do we calculate this? Well, can our dust collector handle it? Yes. If we measure the longest run, which will be from our dust collector up, across, and all the way to the end, going down and into our tube. Now, I'm going to take note here. Nick Engler did not calculate when he did this original one. He did not calculate for the octopus and the 3 hoses going into the dust collector. Now, I can't calculate that just yet because I'm not sure exactly how long the the 3 hoses are going to be if I were to do this. I'll also give you a note that this is not the greatest setup in the world, but what is nice about this setup is, if you so choose, you can unhook the dust collector, move it around to another part of your shop, and plug it into something else, or use it to help clean up the rest of your shop without completely messing up the rest of your system. Alright, now, we're going to calculate this. Well, how do we calculate this? Well, again, we have that chart that shows us everything, but there's one small, teeny-weeny, itty-bitty little problem. You can see all the different choices we have. 3,500, 4,000, and 4,500 feet per minute. Which one do we use? Well, you need 3,500 to 4,000, and it needs to start with 4,000 at the tool. But when Nick Engler calculated in his mock setup, he used 4,500. Now, I think that has to do with the fact that, remember, when we use 3-inch pipe, we can get a really high number of our feet per minute and cubic feet per minute, which was, as you recall, 6,700 plus. So what I'm going to do here is I'm going to give you a calculation of all of it. Well, not the 3,500, just the 4,000 and the 4,500. And we're going to see if we add all of this together with the longest run, will we be under or over that static pressure that we need? Well, let's find out. First, we're going to take the obvious numbers that are listed there, and we're going to multiply them by our parts. So, first, of course, we have a section of 6-foot tubing, or hoses. They count as straight. The only time they're not is if you have a really sharp turn. So, we're going to calculate that. So, remember that chart, our drop in static pressure. So we have for 4,000 feet per minute, 0.120 inches, 4,500 feet per minute, 0.132 inches. So we calculate at 4,000 for 6 foot, 4,500 for 6 foot. So, of course, in case you're curious, that's 6 times 0.120 on the left and 6 times 0.132 on the right. You with me? 2.91 feet coming up from there. We have one 90 degree, and the 90 degree, it doesn't matter the feet per minute, it's all going to be the same. Then we go across 1.5 feet. Now, Nick Engler left out the T connector here, however, I've left it in for extra calculations. Next, we're going to, of course, go across again, and that going across again is 2.08 feet. Now we drop down 4.5833 feet. Yeah, I went a little overboard on that calculation, but that's okay. And then, of course, we enter the octopus. Now, you can see all of these numbers listed down. So, let's add all these numbers together. Let's start with the 4,000. 0.72, 0.0291, 0.375, 0.15, 0.375, 0.208, 0.375, 0.5833, giving us a total of 2.69043. That's how much cubic pressure we have on our longest run, which is a little over half of 4.6. Now that's pretty good. Now, how about the 4,500? Well, here we go. 0.792, 0.3201, 0.375, 0.165, 0.375, 0.2288, 0.375, 0.504163, totaling 3.135063. Again, plenty of static pressure. We have plenty of power. We're doing pretty good for ourselves. Now, there is not really an instance where I'm going to have both of these running at the exact same time. But for fun, because I have a theory on how I could be running both at the same time, let's just math it all together that we're running both. So I've got to do the additional 6-foot hose and the additional footage going up, which of course is, as I recall, 2.91 feet. Well, there you are. Just as I thought. We're doing okay. That's how you get those calculations. You multiply that static pressure drop per linear foot, and you put it all together. Can your dust collector handle it? Something tells me it can. Well, there it is, ladies and gentlemen. The math on can your dust collection system handle the size housing you want to use, and how to figure out, well, if I put one in here, how do I mathematically get it to work so that I have plenty of suction power in one place and the other, and not lose any kind of suction power. And as for those of you shopsmith users who are still going to argue about 4-inch pipe, remember, if you're using 4-inch on a DC 3300, your run must be extremely short in order for it to get to work. Now, those of you who have been wondering about the DC 6000, I cannot comment. I'm seeing mixed reviews, but you know what? I give you a piece of the math, and that's figuring out the velocity in the cubic feet per minute. I can't go on from there. Well, that's all I've got for right now. Hopefully I will see you next time, right here on the Beggars Woodshop.